So the second technique is known as frequency shift keying. As the name is suggesting, here we are changing the frequency of the analog signal to represent digital bits. Here we will have a carrier frequency, and for example, let's say we have a bit of 1, then we will increase the frequency by delta f, and if we have a bit of 0, then we will decrease the frequency by delta f. So based on these changes in frequency, we can uniquely identify either this signal element is representing a 0 bit or 1 bit. So here is an example of binary frequency shift keying. As you can see, for 1, we are using a signal element that has a frequency of 4. Okay, and for 0, we are using a signal element that has a frequency of 2. Okay, so the receiver will count the frequency of the signal element. If the frequency is 4, it will convert it to 1. If the frequency is 2, it will convert it to 0. So this is how the binary frequency shift keying will work. Okay, so this frequency shift keying has basically have two types, that is known as coherent FSK and non-coherent FSK. So what are they? In coherent FSK, we make when we are shifting from one signal element to another signal element, as we can see in the previous slide. This is one signal element, right? And this is another signal element. So when we are shifting from one signal element to another signal element, the phase of these two signal element has a continuity, right? We have indexed this signal element here and started second signal element right from there. Okay, so there is a continuity in it. So this kind of frequency shift keying is known as coherent frequency shift keying. And if we do not care about this continuity, so let's say uh, that one signal element has started from here and end here, and another signal element has started from here and end here, then look, there is no continuity in phase in this frequency shift keying. So this kind of frequency shift keying is known as non-coherent frequency shift keying. Okay, so the basic idea is that if the phase has a continuity, then it is coherent frequency shift keying, and if it has no continuity, then it is an non-coherent frequency shift keying. Right, so there is another example of this frequency shift keying. As we can see, if the bit is 1, the frequency has increased. If the bit is 0, the frequency remains as it is. Okay, so similar to amplitude shift keying, frequency shift keying can also be used for multiple bits or sending multiple bits at a time. Here is an example. As you can see here, we are trying to send 2 bits for each signal elements. So based on this, we have changes the frequencies for each binary sequence. For 00, the frequency will be 2. For 01, the frequency will be 3. For 10, the frequency will be most probably this is 4. For 11, the frequency will be 5 or something. So the basic idea is almost same. We will change the frequency for different bit pattern, and as we have used 4 different pattern, we can basically send 2 bit at a time for each signal element.